So I'm here to talk about the journey to AI, right? The journey towards artificial intelligence and the importance of really having a strong foundation, a strong information architecture that really makes the best use of your data and your information. My job within IBM is to work with the ecosystem, and when I say ecosystem, it is broadly the whole bunch of very bright developers that we have in our country across the various IT companies, across the startups, the students, the smaller partners, so on and so forth. And we, on a day-to-day basis, we really reach out to the communities, reach out to the developers, and help them build the software that Dr. Shetty was really talking about, right? That's really going to change the world, because that's a very powerful statement, right? And more we do see software engineers, software developers hold a lot of power and hold a lot of ability to build applications that really change human lives and change the way we work and we live. So there's a lot of buzz around, there's been a lot of buzz around AI, there's a lot of conversation and a lot of work happening in the area of artificial intelligence. Different industries look at it in different ways, right? So from a very basic consumer focused application level, you look at AI being the ability to see, the ability to visualize, the ability to converse, the ability to understand text, so on and so forth. That's more from a consumer-facing AI that you and I may experience every day through voice-enabled applications and Alexas and those kind of B2C kind of applications. When you look at enterprises and when you look at industries, AI is really about changing the way these various industries do their work, right? So, for example, Doctor spoke about healthcare. How do you employ AI capabilities to really enhance and augment the intelligence that the humans bring to the table and thereby help you scale? So, when you look at the journey towards AI, it is a journey, and today we are dealing with multiple dimensions in which data is coming to us from different sources, right? So it's the mobile, the internet, the IoTs, the sensors, so on and so forth. And thereby, it really changes the way in which we need to look at this data through those various dimensions, visualize the data, understand the data, and thereby deploy the right tools and mechanisms to actually make use of that data. So one problem that we don't have is that there's no dearth of data, right? We live in a world that there is immense amount of data, and you may have heard about this fact that more than 80% of the data is sitting within, right, enterprise firewalls. It's not really out there. So to give you a sense of the volume, right, every day there is around 2.5 quintillion, I don't even know how many zeros that is, 2.5 quintillion bytes of data that is generated every day, right? This is almost 20% more than what it was 2 years back. Thanks to the fast pace of technology, the fast pace of networks, and all the IoT devices that are out there, the generation of data. So there's no problem in terms of not having data. There is a lot of data. But at the same time, if you look at the next big thing, one of the biggest problems, so 80% of professionals spend their time, data professionals spend their time in actually cleansing that data and making it ready for consumption. So if you are in the data science analytics space, you will relate to that very well, right? So one of the challenges is to have clean data, classified data, to really do the exciting stuff that data scientists are supposed to be doing, but then you do spend a lot of time in really cleansing that data. And hence, more than 90% of organizations are not really using their data very efficiently, related to the earlier problem, right? Because it's there in maybe multiple silos, multiple places, and not really pruned for consumption in a very intelligent manner. And then there is the aspect of security. Again, today nothing is private. Anything that is out in the internet is not private, right? It is public data. And you need to tread that thin line between what needs to be secured, what need not be secured, and the cost of a data breach can run into billions of dollars. So from a security standpoint, if you are dealing with sensitive data, you better be dealing with an infrastructure that's going to guarantee that kind of a security. So all of this is again costing you time, resources, and opportunities for your business. This is a maturity curve. So again, when we look at the journey towards AI, more than 75% of businesses are looking to do some level of cognitive, capability infusing into their applications, right? But how many of them are really able to do it? It's not a very big percentage. So if you look at the various functions from that domain, at the very basic level, you try to see how you can really operationalize your data, right? How do you make the data available across the various data sources, easy to consume, and thereby, reduce costs, because you're not really dealing with multiple sets of data. It's all easily available to you. The second piece is where you're a little bit more invested into a data warehouse or a data lake, where you really have a more structured mechanism of consuming that data, making it ready for self-service analytics. So self-service analytics kind of a stage is where you have your line of business users able to consume that data and analyze that data and derive insights of it without really depending on IT tools or the IT teams. So most of the organizations, most enterprises sit somewhere between the second and third pillar there. They are moving away, they are maturing into being a self-service driven analytics based organization. Where we need to get to, again, when we look at AI being one of the larger goals that we want to reach, is really to have transformational new business models where there is much more automation, where there is machine learning everywhere, and where you're really able to make a lot more decisions in an automated fashion with that strong infrastructure in place. So this is reiterating the fact that AI promises to unlock the value of your data in totally different ways, and more than 80%, or around 78% will climb the ladder to AI, in the process of climbing the ladder to AI, and I'll talk about what we mean by the ladder to AI. So this is an interesting study by the MIT Sloan Institute on the effect of how companies are really embracing AI and why it is important to have a strong data platform and data information architecture. The study is available online. If you should read it if you're really looking at this area in detail in terms of actually traversing that journey. And one of the points they make is, again, right, the data collection and preparation are one of the most time consuming parts of deploying AI, and hence the need for information architectures. So there is no AI without IA. So any guesses what is IA? I've already given it out enough my talk right now. What is IA? Okay, good, you're listening. So there is no AI without IA. IA stands for information architecture, and unless we really invest time and resources in building that, that's not going to come just like that. It cannot be an afterthought. So how do we go with that, right? So how do you make your data ready for AI? And there, in the morning, I did listen to quite a few talks where there were several professions or several personas or roles being defined, right, in terms of data scientists, data engineers, developers. I even heard for the first time the data artist, which is a nice way to put a profession, right? The various kinds of roles in a company, in an organization who deal with the data. Okay, so if you look at this over here, you have your application developers. These are your software developers who are building applications, using the data, consuming the data, querying the databases, data warehouses, so on and so forth. So they use the data to surface a self-service application to the end users. You then have the data engineers. So the data engineers are typically, again, data specialists, people who understand that particular subject matter very well, are able to categorize it, classify it, and make it ready for the data scientists. So they sort of sometimes overlap, and there is some level of intersection between what a data engineer does and what a data scientist does. But a lot of the cleansing and the enrichment work is done by the data engineer. Data stewards. Any guesses? What does a data steward do? Keeps the sanity of the data. Perfect, right? So data stewards are responsible for the sanity, for the governance of the data, right? Who uses what, having a unified governance model, ensuring the data is organized in a certain way and is consumed and sanitized in the right way. So those are the data stewards. The data scientists, I don't think I need to explain that over here in this room, but the data scientists are really the ones who really build out the models and, you know, really do the amazing stuff that you can do with all the data out there from an analytics perspective. And then you have the line of business and the analysts who consume the insights and consume the dashboards and make those decisions that are required as you go through. So if you look at all these roles, from an IT perspective, right, from a data information architecture, data platform perspective, it's important to ensure that the tools and the technologies align across this life cycle. And that is where we look at that end-to-end cycle in terms of offering every other persona an integrated view in terms of which how they can deal with this data. So first of all, you look at, you know, how do you make your data simple and accessible to use. So it may sound simple, but that involves, you know, collecting every data. So every data is important data. You don't really throw away data, right? So any data from any source, how do you collect it? These are, again, in large enterprises, you're talking about multiple silos within the organization, multiple different types of data sources. There may be, traditional databases that may be in some of it is in a cloud-in database, some of it is in a different cluster. How do you sort of collate and collect it? And then you sort of organize it to build a trusted analytics foundation. So the foundation should be built on top of those multiple data sources, which sort of stitches that together. And then how do you scale it to deliver the insights on your demand? So at the very foundation, what we look at, the technologies that really help you facilitate this vision that you see starts with building a cloud native based foundation. And when I say cloud native, it's about building a foundation which is ready for the cloud. And we use technologies such as containers, microservices to really ensure that it is cloud native. And then there is the debate of whether you should keep it within your premise or outside your premise, and we'll talk about how you can interchange between the two. Okay, so we do believe that companies will revolutionize the way in which they consume and use and apply the data. This in turn is going to be facilitated by a lot of machine learning. So machine learning is, of course, at a very evolved space within the AI ladder, right? So most of us are today maybe doing analytics and a little bit of automation, but really to unleash machine learning, you really can't do that if you finish those first two steps, right? So machine learning everywhere to really automate the AI process, facilitated by a uniform architecture which is cloud native from day one. And in today's day and age, some of these things are there in bits and pieces. It's these guiding principles that will help you really ensure that you have that foundation in place to get where you want to be. Okay, so containers. So what is a container? Anyone who knows containers or containerization? Yes, there's one person. Without knowing the underlying system or the thing, right? So yeah, thank you. So containers are nothing but self-contained units, right? So when you think about containers, the thing that may come, visually are those large shipping containers, right? Where you have that box, and within the box you have all your goods, and it's loaded onto the dock over there. In the AI cloud world, right? A container is nothing but a self-contained unit which consists of the required environment, the software, and it's sort of like a operating system self-contained with it, right, where the application runs within that unit, right? So it's easy to plug and play that containerized application from one environment to the other. So it's really not having any dependency on the underlying hardware or the underlying operating system. It can pretty much run on any other cloud native platform. Okay, why is this important from when we are talking about data? Why are we talking about containers? Why it is important, again, if you go back to what I was saying in the beginning, right? So data comes from multiple sources, right? And you really need to mobilize that data to derive insights out of it. So data-based containers is one of the primary use cases for containerization today. So as more and more enterprises are moving towards AI, moving towards cloud, not everybody is perhaps jumping on the bandwagon of putting everything on a public cloud, but they're definitely looking at building cloud native applications, right? So today there may be 10 applications, out of which 9 you may want to still keep within your data center, within your enterprise. The newer ones you may want to put it on an externally managed third-party cloud, but at the end of the day, all the architecture is uniform, right? So you are building on a cloud-native containerized architecture so that you can live in a multi-cloud world, right? So where you can live in a hybrid world where some of it is with you and some of it is out there, and you leverage the operational costs, the capex costs, benefits that you have of having that kind of a hybrid setup. So one of the bare foundations of building an information architecture is to have a cloud native based platform which is based on microservices. Again, microservices are small, look at them as very small operations or functions that do self-contained pieces of work within their own units, and then thereby also have a container management system. So Kubernetes is one of the most popular and most well accepted standards in this space, where we use that to not only manage the various containers but also to manage the workloads. Okay, so when we go back to the ladder to AI, right, there are 5 steps and we'll talk about each one. So collect is making the data simple and accessible. So there you look at multiple data sources. They may be within DB2, Hadoop, Cloudint, multiple sources. How do you collect and make it accessible? That's the first step of the ladder. How do you organize the data using a simple analytics foundation? So in the beginning, you need a hybrid data management solution that works both, with traditional databases and the newer NoSQL kind of databases. Organizing is to create a trusted analytics foundation. So this is basically to create, to have the right set of tools to do the analytics, right? So this could be SPSS, this could be Cognos, building those kind of analytics reports on top of that data, and thereby analyzing it. The automation piece is about applying machine learning everywhere. So once you have, crossed the barrier of the cleansing and the enrichment of the data, is when you can derive machine learning at scale, right? That is when the data engineers and the data scientists are able to, to populate multiple data sets and build the kind of machine learning models that they want to do. And if you really enter into a much more mature cycle in that particular stage where you're looking at applying machine learning everywhere, you can even apply machine learning to automatically classify and train your models as well, right? So that's the level of maturity that we look at. And the fifth piece over here, which is trust, is again a very, very important piece. So, and somebody brought this up in the previous talk in terms of trust and transparency, right? So in any system, we do expect a certain level of trust and transparency to be built in. And that is where we look at any AI system that we build should be able to justify the decisions that are being made, right? So if an AI system is going to automatically tell you that, this is based on your symptoms and based on your previous health history, this is the kind of analysis and this is the kind of insight that I have gained in terms of a diagnosis in the case of a patient over here, how do you trust that? How do you know if the decision that was made is the right decision or not? So that is where we have a trust and a transparency framework built into it, where any decision being made which is being presented to a business user is justified as to what were the data points that were used to derive that decision, right? And in case that is, it's a wrong diagnosis, or there is discrepancy in the way that it is being, inferenced, there is the ability to go ahead, change that and improve that, right? So it's going to be a very, very important piece as and when we see more and more AI-based, applications coming in to really understand what's going on, inside, right? When you're really ensuring there is no bias, for example. There's one thing about human bias, right? You really don't realize you may have conscious and unconscious biases against certain genders, against certain parts of the, certain kinds of people, so on and so forth, which sort of seeps into your decisions as human beings, right? When you're training a system, it's quite possible that human biases can seep into the system. So how do you remove biases? So, having a system to detect biases and remove biases, those are some of those things that are, again, part of that trust and transparency layer, which is a very important piece when you're looking at building an AI system. So, so you will realize I'm talking in a very generic fashion. I'm not really making it very prescriptive. These foundational principles apply to any platform, right? Whether you're building out your AI system using open source, whether you're building out using commercial software, these are the things that you need to ask, you need to question, and you need to ensure is part of your architecture, right? So from the IBM side, right, we have, and this is a good picture to take, this basically shows our view of an integrated information architecture to power an AI system. Okay, so this is powered by the IBM Cloud Private for Data, which is, to my earlier point, is based on a cloud native architecture powered by Kubernetes, and it also has enterprise data cataloging capability, right? So the first phase that I talked about of having the ability to collect data across fast data, databases, data warehouses and everything, you can actually then classify that data with metadata into an enterprise data catalog. So that enterprise data catalog sort of becomes your master catalog across the enterprise, which sort of becomes the place where you start with finding and using that data. Organizing it, the role of the data steward in terms of organizing the data, ensuring that it is governed in a certain way, the use of the data is governed. We have a governance framework and a set of capabilities that help you govern that data. And then, of course, analyzing the data using visualization, using machine learning and deep learning models, applying the right kind of algorithms to actually consume that data. All of this forms those three basic building blocks on top of which you build your microservices, right? So depending on the industry, on the kind of segment that you're servicing, you have to really think microservices based, not really large monolithic applications, which can then be composed into larger solutions with, of course, the dashboards and so on and so forth. So if you look at, again, the top layer, there are tools and technologies within the cloud private. There are quite a number of tool names which I did not want to bring up here and confuse everyone, but it is a singular dashboard which can be repurposed for the roles in your company, right? So if you are a data engineer, right, you will have access to the enterprise data catalogs to actually collect and cleanse and use the data. If you're a data scientist, you're going to use something known as the Watson Studio, which helps you to do the model development, analysis, so on and so forth. So depending on if you're the data steward, you use the governance framework that we have. So depending on the persona, you're going to use various portions of this underlying platform, but it all sort of feeds one into the other. The other part of this is this is the snapshot of Watson Studio, but just on the other point I wanted to make is all those capabilities you see there can be deployed in a private instance within your firewall. are also available on the public IBM cloud, right? So the migration is very, very seamless because it is all cloud native at the end of the day. So Watson Studio is one of the de facto tool sets, right, integrated tool set for the data scientist. And there are several members of my team who are here who are doing sessions on this, which are a little bit more technical, more hands-on, where you can really see the various features of Watson Studio depending on the role that you perform, right? So it has an integrated user interface where you have various developer APIs, so the various basic APIs for AI, right? So be it natural language understanding, vision APIs, speech to text, tone analysis, all those basic AI APIs are available. You can also then create your, bigger applications using, say you want to build a chatbot or you want to build a conversation service. There are services, there are composite applications on top of that. And then there are the various use cases based on which you can actually build. So I would encourage you to attend some of the sessions that are happening later today on some of the hands-on activity around this. So this is just another deeper view into Watson Studio. Okay, so the machine learning models, the metadata, the data catalogs that you create as a part of that process, there is an end-to-end enterprise AI lifecycle. So you may build it within on-premise, you may build it within your enterprise, you can easily publish it to Watson Studio, you can take it to a public cloud, you can keep it in your private cloud. We also believe in embracing the ecosystem, so we do work with multiple other open source frameworks and open source standards, so it's not really something that will work only on our environment per se. Okay, so yeah, so that was the open source interface that I was talking about. So in terms of really looking at expertise, right? So this is all nice to see. How do you sort of realize this, right? So how do you build the expertise within your organization? And if you remember, there were various roles that I called out, right, of data engineers and data scientists and data stewards out there. Each of these require a certain set of skills, a certain set of resources required to build those skills. You also need to, be part of the right level of communities. Events like these are a great ways to learn, but when you go back, you really need to continue from that learning process. So from that area, we do a lot in terms of sharing expertise, sharing our knowledge, and ensuring there is a lot of experiential learning as you go through. So our team does a lot of workshops, we do a lot of meetups, we try and participate in conferences like these to really go through some of those use cases in a more deeper format. Those of you who are software developers who code for a living, who build applications within your organizations or for your clients should definitely visit the developer.ibm.com website, which has undergone a lot of refresh, right, given the newer technologies that we are dealing with. And one of the most popular pieces out there is the code patterns that you see, right? So here, these are open source reusable code. So if you're trying to build out an application, for a given industry or for a given use case, the chances are most probably there is a code pattern out there which sort of talks about the various components of that use case, gives you step-by-step instructions, and you also get access to the source code from GitHub. So you use that as a starting point and then build on top of that. So you really do not always start from scratch. You start with those building blocks and then build the applications for your particular requirements. So strongly suggest that you rather bookmark this website. There are also other how-to material, tech talks, and other material that will help you sort of build on top of that. And it's not definitely restricted only to AI and data science. You will also find a lot of material on technologies such as blockchain and IoT and a whole bunch of other stuff. So, okay, so so this is an example of a journey to AI. I think it's getting cut over there, but again, this is a sample set of code patterns, right, that you could actually use. And some of these have actually been used by our clients to go ahead and, build something really bigger, right? So ICICI Prove is one of the clients we worked with early last year to help them build conversational agents using the Watson APIs. And some of those patterns were used as building blocks, and a lot of it was done by the client themselves with very limited assistance from the IBM team to go ahead and build those conversational agents. So again, different industries are adopting it in different ways. Most of last year, there was a lot of thing around conversational agents, which continues in terms of chatbots, so on and so forth. We are seeing more coming in from, the structured, unstructured data, using discovery services to build insights, to build, advanced analytics, so on and so forth. So there's a lot of content out there. And we also work with some of our large enterprise clients in a more structured fashion. So if you have a certain set of requirements where you want to work with your engineering teams or your development teams to really not only build the skills within the team, but also help them, be a part of your data journey or AI journey, we work with them hand in hand through a very capability building approach. So it's not about training somebody, it's about working hand in hand to really co-create and build. Because as I said in the beginning, right, we believe application developers hold a lot of power. It's just that we are not unleashing that power in the right way. They also hold a lot of influence. We live in an open source world, so there's no stopping anybody from adopting the technology of choice. There's no stopping anybody from having capacity, right? I mean, access to a lot of hardware on the cloud. You can pretty much run tons and tons of transactions, right, if you have access to a cloud environment. So we do work with a lot of large and small organizations, helping their developers not only learn but also differentiate using some of these tools and technologies. And we do it through various ways. We do workshops, hackathons, meetups, POCs, so on and so forth. Okay, so to sum it up, and I would, before I sum it up, right, I would encourage you to go ahead and attend some of the workshops and the other smaller tech talks that we are doing, which goes a little bit more deeper with much more experiential learning in terms of the tools that I talked about. But to go back to, the overall message is, AI is cool, AI is great, right? We all have the data, there's no dearth of data. But we really need to invest some time and some effort and resources in ensuring we have a very strong data platform, very strong information architecture to really make that AI work, right? To really get the benefit of that, to really automate and have machine learning unleashed within your organization. It's important to have that kind of a, strong information architecture. So, with that, I think I have a few minutes to answer questions, if there are any.
Yeah, this is Srinivasan. We have so many technologies for creating or using the AI, but still we question the data quality. If the data is very poor, then you cannot use it, the AI. Just I want to know your approach, like if the data quality is not good, why can't we find any technology that can be used? Since if the company is there for 40 years of data, I cannot rewrite all the data for the most technological format to use the machine learning.
Yeah, so quality of data, so that is where, to my point in the beginning, right, a lot of time is really spent in cleansing that data and making it ready for consumption. I'm sorry, I'm really not able to see who's asking the question. Okay, yeah, so it's not about, you do spend a lot of time enriching and cleansing that data. There are tools to answer your question. There are tools and technologies to enhance the quality, right? So there is data stage, quality stage software, depending on the industry that it belongs to or depending on the domain that it belongs to. You can run those tools to actually enhance the quality of the data. So it need not be an entirely manual exercise. But as long as you have the data and you have some reference point as to what a good quality data looks like, you can really do some level of automated cleansing as well.
Okay, yeah.